In January 1969, an American nurse working in northeastern Nigeria developed what looked like an ordinary tropical fever. At first, the doctors suspected malaria, then typhoid. They tried the medicines available to them, but nothing worked. Her fever climbed. Painful ulcers appeared in her mouth and throat. Her strength disappeared. Her name was Laura Wine. Within days, she was flown hundreds of miles to a larger mission hospital in Jos. She died soon after arriving. Then the nurse who had cared for her became sick. Then another. The illness crossed from one hospital bed to the people standing beside it. Before anyone understood what it was, 2 nurses were dead, a third was being evacuated across the Atlantic, and blood from the victims was on its way to a laboratory at Yale University. There, the scientists trying to identify the disease would become its next patients. This is the story of Lassa fever, a virus discovered through a chain of infections that began in a small Nigerian town and ended by changing how the world handles dangerous pathogens. The town of Lassa lay in the savannah of northeastern Nigeria, far from the research hospitals that might have recognized an unusual disease. Laura Wine worked there as a missionary nurse, supervising the obstetrics ward of a small clinic. When she became ill, nothing about the first symptoms suggested a new virus. Fever, weakness, and headache were common signs of malaria, typhoid, and several other infections found throughout the region. But Wine did not improve. Anti-malarial treatment failed. Antibiotics made no difference. Her condition worsened, and the ulcers in her throat made eating and drinking difficult. The clinic lacked the equipment needed to support a patient deteriorating so quickly, so her colleagues arranged an emergency flight to Evangel Hospital in Jos. The transfer did not save her. Wine's death might have remained an isolated tragedy in a region where severe febrile illnesses were common and laboratory testing was limited. Her case could easily have been recorded as another unidentified infection. Instead, Charlotte Shaw became ill. Shaw had helped care for Wine in Jos, including cleaning the lesions inside her mouth. Contemporary accounts noted that Shaw had a small cut on one finger, offering a possible route for infected fluids to enter her body. Soon after Wine died, Shaw developed the same fever and throat symptoms. The medical staff watched the pattern repeat. Treatment failed, her condition declined, and she died. Now the hospital had a problem that malaria could not explain. 2 nurses, connected by direct patient care, had died from nearly identical illnesses. Whatever had killed Wine appeared capable of moving between people. A third nurse, Lily Pinneo, known as Penny, had cared for Shaw. Before long, Pinneo also developed a fever. The hospital faced a terrible calculation. If she remained in Jos, she might become the 3rd nurse to die. But moving her meant placing an unidentified and possibly contagious illness on an aircraft, carrying it through airports and across national borders. Doctors chose evacuation. Pinneo was flown from Jos to Lagos, then across the Atlantic to New York. She was admitted in isolation at Columbia Presbyterian Hospital, where physicians tried to keep her alive while investigators searched for an explanation. Unlike Wine and Shaw, Pinneo survived. Her recovery made her more than a patient. It made her the most valuable source of evidence in the investigation. Somewhere in her blood was the agent that had killed the other nurses, along with the immune response that had allowed her to live. Samples from Pinneo and the deceased nurses were sent to the Yale Arbovirus Research Unit in New Haven, Connecticut. The laboratory specialized in viruses transmitted by insects and animals. Its researchers were accustomed to unfamiliar pathogens, but the precautions available in 1969 were far less advanced than those used for high-risk viruses today. Virologists Sonia Buckley and Jordi Casals began trying to isolate the agent. They introduced the samples into cell cultures and laboratory animals, watching for signs that something inside the blood was reproducing. Eventually, they recovered a virus unlike any previously identified in humans. Under the electron microscope, the particles had the grainy appearance associated with a group that would become known as the arenaviruses. The new virus was named Lassa, after the town where Laura Wine first became ill. The disease finally had a name. The danger was not contained. While working with the new virus, Casals developed a fever. The man helping to identify the pathogen had become infected by it. There was no approved antiviral treatment, no established protocol, and little experience treating the disease. Doctors turned to the one person known to have survived it. Pinneo's blood contained antibodies produced during her recovery. Plasma was collected from her and given to Casals as an experimental treatment. His condition later improved and he survived, although the treatment's exact contribution could not be proven. Then another Yale worker became ill. Juan Ramon was a laboratory technician. His infection was especially alarming because accounts indicated that he had not directly handled the main infected specimens or experimental animals. Investigators could not determine with certainty how the virus had reached him. Ramon died. The Yale infections transformed the Lassa investigation into a warning for the entire research community. Work with the virus at Yale stopped, and surviving samples were transferred to a maximum containment federal laboratory in Atlanta. High-security laboratories already existed, but the Lassa cases added urgency to the development of stricter containment, oversight, and training for researchers handling newly discovered pathogens. The lesson was clear. A laboratory could understand a virus scientifically and still underestimate how easily it might escape the procedures meant to contain it. By then, investigators knew what caused Lassa fever. They still did not know where it came from. Viruses that repeatedly enter human populations usually survive in another species between outbreaks. That animal is known as the natural reservoir. It may carry the virus without becoming visibly ill, allowing the pathogen to persist until contact with humans creates another opportunity for spillover. The search took investigators beyond the hospital and into homes, farms, and villages. In 1974, during an outbreak in Sierra Leone, researchers trapped and tested local wildlife. They isolated Lassa virus from Mastomys natalensis, the multimammate rat. It was not a rare animal hidden deep in an untouched forest. It was one of the most common rodents living around people in West Africa. The rats entered houses, nested near stored grain, and moved across cooking and sleeping areas. Infected animals could shed the virus in urine and feces without appearing sick. Food, household objects, and dust could become contaminated. A person did not need to be bitten. Contact with contaminated material could be enough. The reservoir explained how the virus could appear without an obvious chain of sick humans. It also explained why eliminating the threat would be so difficult. The animal carrying it had already adapted to life beside people. The discovery of the rat solved one mystery, but later research complicated the origin story. Laura Wine was the first recognized patient in the outbreak that led to the virus's discovery. She was not necessarily the first person infected. Decades later, researchers tested blood from Harry Elia, a missionary who had suffered a severe fever and sore throat in Nigeria in 1952. Elia survived, but doctors at the time never identified the illness. More than 50 years later, his blood still contained antibodies consistent with past Lassa virus infection. He may have encountered the virus 17 years before it had a name. That finding revealed the central truth of the story. Lassa fever did not suddenly appear in 1969. It had likely circulated unnoticed, disguised among malaria, typhoid, and other common causes of fever. The incubation period can last from 2 to 21 days, creating another obstacle for investigators. A nurse might care for a patient, continue working for more than a week, and only then become ill. Transmission between people is associated mainly with direct contact with infected blood or other bodily fluids, particularly in healthcare settings where the disease has not yet been recognized. There is no evidence that it spreads between humans through the air, but that offered little comfort in 1969. The nurses in Yos were treating what appeared to be familiar infections without knowing that routine care could expose them to a different danger. Even today, that disguise remains one of its greatest advantages. Most people infected with Lassa virus develop mild symptoms or none at all. Severe cases can involve low blood pressure, organ dysfunction, swelling, shock, and in some survivors, permanent hearing loss. Dramatic external bleeding is not the defining feature many people imagine when they hear the phrase hemorrhagic fever.
Early diagnosis is difficult because the first symptoms resemble several other diseases. Supportive care can improve survival, but there is still no approved antiviral drug or licensed vaccine specifically for Lassa fever. Ribavirin has been used for decades, although uncertainty remains about how effective it is and which patients benefit most. The virus remains endemic across parts of West Africa. Human infections continue because the reservoir is common, household exposure can be difficult to prevent, and the earliest signs of illness are easy to mistake for something else. But the events of 1969 changed how the disease was seen. Laura Wine's unexplained fever became a hospital outbreak. Charlotte Shaw's death revealed that the illness could pass through patient care. Lily Pinneo carried the evidence across the Atlantic and survived long enough to help identify the virus. Jordi Cassells became infected while studying it. Juan Ramon died inside the institution trying to contain it. Pinneo eventually returned to Nigeria and continued working in medicine for years. The story of Lassa fever is often described as the discovery of a new disease. That is only partly true. The virus was not new. What changed was that for the first time, a scattered chain of fevers, deaths, and laboratory infections was followed far enough for the hidden pattern to become visible. The threat had been present for years, perhaps far longer, inside ordinary houses and common rodents. It did not arrive with an explosion or a warning. It entered through contaminated dust, a patient's blood, and possibly a tiny break in a nurse's skin. By the time medicine gave it a name, it had already crossed an ocean and entered the laboratory built to expose it, forcing science to reconsider what containment truly meant.